welcome to everybody. Welcome to Liverpool John Moores University. My name's Keith George. I'm the PVC for Research and Knowledge Exchange. And along with other exciting days like graduation and university conferences, these are the days that I really enjoy because we get to hear the stories of our people. And at the end of the day, universities are about collections of people and how they interact with each other, how they work with their partners, their stakeholders outside of the university. And when we see success stories like this, it makes you proud to be part of this community and part of the higher education community. I'm going to read a little bit of Patryk's background because I think it's really important to understand where Patryk has come from and what he's achieved. So Patryk is Professor of Microwave Sensor Technologies and Deputy Director of the Built Environment and Sustainable Technologies BEST Research Institute here at the university. Patryk leads a multidisciplinary team in design and development of bespoke microwave sensor technology that he applies to global challenges with his partners around the city and around the globe. The focus of these sensors is real-time detection, and you can't buy the quality and importance of real-time assessment and detection when it comes to science. And he's worked on these particular topics for many years. But I think the one thing we've got to realise is how rapid Patryk's progression has been. So Patryk completed his PhD, I believe, here in 2017. So although I can't call Patryk a son of Liverpool, he's definitely a son of Liverpool John Moores University, and that is important for us to note. The developed work, the algorithms, the concepts, the collaborations with Janet and her team at Liverpool School of Tropical Medicine have all followed that PhD success, and it's led to some fantastic, impactful and transformative work going across various areas of Africa, India and other parts of Asia. The developed prototype is undergoing final stage trials, and we look forward to seeing some real significant impact and development of those technologies as they go to manufacture, hopefully this year. The success of the project has led to further external funding. The Melinda and Bill Gates Foundation funding is a key one with collaborators. And what's really impressive to me is how that original idea has now mushroomed into an impact on multiple areas of society, locally and internationally. There's work with biohazard detection with DASA, healthcare applications, UKRI, cultural heritage through a Horizon 2020 grant. So, Patryk, this is a real wonderful opportunity to hear your story and for us to share in your celebration. And sometimes when you come to these events, you want to try and encapsulate the people who are presenting in a small number of words. And I would say creative, passionate, collaborative, with real impact. And you can't ask for more from our academics than that combination of skills and ability. So it's with great pleasure that I invite you to come and share your story with us.
I think we might going to have a guest on the stage very shortly. Professor Keith, thank you very much for your kind introduction. All the guests, I would like to thank you for coming to this lecture today. Vice Chancellor, for Vice Chancellors, also my family for finding time and coming here, so thank you very much. So today I would like to talk about breaking boundaries using microwave technologies. And why breaking boundaries? The microwave technologies offers some fantastic opportunities like adaptability, flexibility to various opportunities, various applications. And that's what I found very interesting throughout being at LGMU. So that's something I would like to talk through today. Yep. So before I start in the lecture, I will go back many years back ago, so back to 1990. That's when I was born in Poland, in a little city called Rubartów, which you can see where this red cross is in sort of that area here. Only little town, 25,000 people, so pretty much everyone knows each other. And in the background, you can see those three sort of buildings. They're not prisons, they Polish schools. So I know they could look quite scary, but starting from the top, the primary school, you can see my picture on the first day when I got my first student ID. And then second school, which is, we call them gymnasium, it's sort of GCSE level type school. And then the one on the bottom, sort of A level, so we call them Liceum. So that's where I was studying. And since sort of early stages, I really like engineering, technologies, IT. So for all those years through the GCSE up to A levels, I was in a mathematics, informatics style profile, just to get those additional skills in that area. But as always, your parents always look after you. And in Poland, we've got that saying that if you don't want your kids to get into trouble, you just put lots of activities on them. So I've been doing taekwondo since early stages, all the way through pretty much to A levels, 4 times a week. And then I was doing music school for 5 days a week, playing on saxophone, drums, and piano. So I got quite a lot of activities, quite a busy schedule since early stages. But I didn't really think of that at that stage, but actually standing down here, you can sort of realize that those skills you're learning as a kid, where you're sort of gaining the experience of meeting deadlines, coming to time, and sort of being able to adapt to various situations, deal with multiple things at the same time. Those skills are the ones you're gonna sort of acknowledge when you're in the position of doing research. So for that, I would like to really thank you, Mum, for putting that me through. So from there, very little short journey of what I've been doing in LGV. So starting in 2009, that's when I moved into Liverpool. I started with a BSc in computer technology. Then 2012, I went into MSc, microelectronics system design. I also had my daughter at that time. 2013, I started my PhD, also at LGMU. And I never forgot at one of the sort of supervisor meetings, one of my supervisors advised me, never get married during the PhD project because your social life will disappear. You need to focus on your project. Well, I don't tend to listen to those. I like the challenges. So I did get married in 2014 while doing PhD. And up to now, it's been 10 years, actually this year, this summer. So far, so good. So thank you very much, my wife, for the patience. And sort of supporting me as well throughout this time. From there, while I was in the writing stage mode for my PhD, I joined my first research assistant position in a healthcare technologies project, which I will touch on later on down the line. It was 6 months fixed position. So the next one, energy from waste. So again, you can see, you will find out today that there's loads of applicability to the sensors and how they can stream from different projects. 2017, I had my final research assistant position in underwater sensors technologies, and in 2017 March, I became a senior lecturer within civil engineering, also at LGMU. So 2019 got promoted to the readership, 2021 promoted to the professorship, and I also had my son, which you can hear in the background. I'm surprised that he's still sitting quietly, nicely there. So as you can see, I sort of feel like being a LGMU home-based product. But the warranty is already gone, so we're not accepting any refunds at that stage. So taking from that, going towards the engineering, how my journey started. I mean, you can see me sort of walking quite stable, but actually engineering wasn't never my first choice. So initially, I actually applied for the architecture course within LGMU. So I'm not sure how sort of this happened that LGMU sort of kept me as a magnet, but I did apply for the architecture initially. But there was a lot of challenges between postal services, UK, Poland. So by the time I got the letter asking for some drawings, the deadline was already gone. So then I sort of start looking into alternatives, and you can see sort of second picture, sort of when you're falling down, the family is always there to back you up. And I sort of make a decision to move towards engineering, and I accepted the computer technology course. But down the line, I started looking through the pictures when I was preparing this presentation, And I've noticed loads of pictures with myself as a kid with a microphone. So I sort of start thinking, did my mum already know that in the future I might need those skills of the presenting, because there were so many pictures where I was already doing some sort of presentations. But I started the computer technology course. So at that stage, I still had loads of hair. I mean, who knows me now? I'm quite bald. So I've lost that throughout the time at LGMU. Lots of fashion was going there at that time as well. But that was the time not just to study, but also to make a friendship. So that's the first time when I actually met Mo. Again, who knows us working here? We always work close to each other for the past 15 years now. So it's very important to do those long-term friendship collaborations where you can rely on other people. So as a part of the bachelor's program, my final year project was related to basically developing a wireless bomb disposal robot. So since beginning, when I was thinking about the research, I really enjoy being able to apply that research into a real-life scenarios. I didn't sort of think of a blue sky research as such. I really was focused on thinking of something that can impact outside of the academia. So at this stage, I would really like to thank all the people, obviously in EEE department and computing, who were behind me, supporting me with that project. Because obviously the project was quite complex. It required mechanical engineering, hardware, software engineering. So there was a lot of things that obviously at the early stage of your studentship, it was quite difficult to gather everything. So I had loads of support and guide, which I really appreciate with LGMU. To be able to sort of complete the project. And I still remember how that robot was going through the corridor of the 5th floor in James Parsons building. I mean, now we've got Spot the Dog, so we've got 2 of them actually, so we can see how the technology is moving forward 10 years later, 15 years later nearly. So we can see how the technology is important and how quickly it can progress from one to the other. So some good memories as well, graduations, which we mentioned. They are fantastic events, so obviously very quick snapshots of friendship, family gathering together on one of those graduations day. And then we move into microelectronics system design module program, also at LGMU. And at this stage, I need to apologize actually to one of my professors. I'm not going to mention the names loud, but that was the time when my daughter was born, so I did have to get a full-time job to support the family. So I did work 13-hour shifts, Friday to Monday morning, 6 o'clock. And I had one module scheduled for Monday, 9 o'clock in the morning. And I was working at Airport area Speak, and I live in Wirral. So the commuting time to get home, change, get showered, come back to uni, basically I didn't sleep. So on these lectures, usually I would have a short nap, And at this stage also my colleague would always try to wake me up and sort of keep me awake, which was fantastic. And I wouldn't be so worried, but if the class would be full of students. There was only 5 of us in the class, so I'm sure that didn't left unrecognized. I mean, thankfully I did successfully complete the program, but that's one sort of memories I got at that stage. Now, the other quite a pivotal time in my sort of career was actually conversation with Carl Jones that I had, because initially my idea was to complete MSCs and go into the industry, because I was hoping of sort of doing some real impact in there. But having a chat with Carl, he sort of talked through about different opportunities that we do offer in the university, and he met me with those 2 sort of dodgy characters in the background, Ahmed and Andy, who sort of introduced me to BESS and showed me that you can actually do impactful research, applied research. So I joined the group through my MSc project. Hello. So I was part of the funded project through Stagecoach. It was a development of the modular multi-channel GPS environmental logger. And at that time, I learned 2 very important things. One is keeping the deadlines, because again, with industry, you cannot afford to sort of delay things, so you want to have things organized on time. Secondly, you had to learn how to quickly mock up certain prototypes, because if something goes slightly wrong, there's some challenges. You sort of have to keep everything quite quickly. Hello. So, you can see in the background this sort of pot noodles with the electronics. So that was our sort of initial design, just to sort of meet the requirements, can we collect the data? But down the line, we have managed to organize a bit more PCB approachable system, which could be installed into this system with a gas analyzer, you can see on the top. And actually, the thing I did enjoy, it actually went live into the Stagecoach buses. So I could see how from MSc project, from a tiny prototype, it went actually to the full-scale buses trials. You can see a loop that the buses were driving around Merseyside area, Liverpool area, and you can see a snapshot of the software I've developed to allow you to capture the emissions, the speed of the vehicle, and the location of the vehicle in real time. So that was something really interesting for the company, because based on that, we managed to secure a European project which took it further and compared different types of engines in the vehicles to see how obviously environmental friendly they are in different scenarios, as well as obviously there was a follow-up project, it's called biodye project, which I will talk in a minute, so I'm not going to focus on that too much at the moment. But also, at this time, another thing that was kindly assigned to me is I did receive a full-time PhD scholarship with LGMU. So I was quite fortunate throughout my study that there were so many opportunities for me that I really appreciate that the LGMU offers, from bachelor's to master's to PhD. It's really nice to see the opportunities down there. So I've been working on the project called Feasibility of Using Microwaves in order to determine the moisture content in building fabrics. And what inspired me in that, it was non-destructive. So you actually didn't have to touch any material. And it's like science fiction, how can you come close to the wall and it will tell you if it's moist or not? So it was really, really interesting to me to see, can we actually develop that kind of technology? I also learned one more thing. So during end of MSc, beginning of the PhDs, together with Mo, we've always been searching for our supervisors. We would go to the lab 8 o'clock, 9 o'clock, 10 o'clock, they're not there. We will go to the office, they're not there. By accident, we go to Starbucks. Guess what? All of them are there. Since then, we've learned that if you're looking for the supervisor, it starts with Starbucks rather than the office, and I'm sure you will be successful. So till now, when I do the PhD mentors training, I do sort of advise students, have a nip in Starbucks. They are the best places to have those initial conversations about the opportunities. Obviously, PhD is not only about the study. There's always important to make a team, build up that sort of team ability, community. Again, so the research community is very important, and that's what sort of PhD allows you to do. And also memories that you're going to obviously have with you throughout your rest of the life. So it's important to do that as well. Don't forget about that part. But also, again, opportunities. So I think that word will be coming through very often today, is being able to see them and also to capture those opportunities. So while I was doing PhD, there was a tour around the labs with Professor Mike Riley. He brought his a colleague, friend, Professor Aslan from University of Malaysia, and they were interested in looking at detection of membrane failures in concrete flat roof structures. And obviously, they've seen the technology I've developed as a part of my PhD, monitoring moisture in building fabrics. Here is monitoring sort of leaks in the concrete. So why not to try? So we've done a very quick and try experiment, which was very successful. So that allows us to build up some collaboration. We've actually built replicas of mini roof structures according to obviously Malaysian standards to make sure we sort of try to make it as real as possible. And probably at this stage, my sort of a small message to all the ECRs is to try to get your hands dirty. Yeah, don't leave all those things, for example, for technicians to build up for you. Because while you're building those things, it's one thing to do a model, one thing to do the simulation. But actually, when you try to build it up as an experiment in the lab, there will be loads of obstacles you might find out. And if you don't get yourself dirty, if you don't want to try to find it, you might not find them. And then again, you're going to have to repeat the entire process. So I do like to be in the labs. I do like to sort of help around and sort of see if there are any opportunities for various things. But also, this was the time when, as a PhD student, I published my first paper. It was a collaborative paper with Mike, Andy, and obviously Professor Aslan. from Malaysia. It was Q1 paper as well, probably 3-star paper right now. So as a PhD student, I was quite proud to get that first publication in a collaborative sort of system. So I did really enjoy that time of that collaboration. And from then, again, you're getting those sort of wacky ideas. You know, we've been developing non-destructive testing from the distance, how we could deal with a long-term monitoring. Can we do something about it? And we thought, like, what if we throw the antennas inside of the concrete? What's going to happen? And without really thinking twice, we've just implemented a couple antennas into the concrete structures. You can see concrete cubes you can see in here in the bottom. We've developed associated circuitry to drive that antennas inside of the concrete, and the tablet applications, so you can actually see all the real data coming from the concrete. So if you wet it, you can see how the parameters are changing. So it gives you the opportunity to basically expand the project going forward. We had a few industries very interested in that, although there was no the right funding landscape at the moment. But again, I will come back to that with the other project to explain how actually those ideas can come back with the right time. So that was the completion of my PhD. So again, a nice family time with a graduation at LGMU. So again, with the family friends. And that's the first project I was undertaking as a research assistant. So it was a funded project, again, through SBRI. I joined it as a phase 2 project. And my job was to optimize the technology, the circuitry, into something that can be wearable. So the whole concept of the project was called Warm Dry. So it was about making children aware that if they need to go to the toilet, the technology will pre-wake them up so they will not wet the bed, okay, at night. So as you can see, there is very little technology on the top, prototype, which again, in real time, you will be able to see how the data can be captured. And that data will be then connected to the application that is developed on the site, which will pre-awake the children so they can use toilet appropriately. But also it will keep a long-term schedule so the parents can see if the person is sort of accommodating to that, if the child is sort of learning as it goes, or if not, what are sort of conditions and situations like this. So again, it was quite a nice little project. From there, yeah. Because of the obviously fixed term position, it was 6 months contract, I had to adapt a little bit. So I had to leave microwave sensors for a moment, and there was an opportunity again which been best to join another funded project, Innovate UK project, led by the company called Stopford, and it was a project around torrefaction. So again, renewable energy is now a huge, sustainability is increasing. I mean, that's back to 2019, I would say, even 18 maybe. So it's still a few years back. And the concept was to basically torrefy the wood using microwave plasmas, basically. Torrefy the wood in order to reduce their overall weight, but also increase their calorific value. And my part of that job was to develop the automated system, which will be able to control the microwave plasma system, as well as capture the temperature profile across the chamber, so we could see how the entire temperature distribution is taking place in the torrefaction unit. But again, opportunities. While I was developing this system, there was another parallel project called gasification, still microwave plasmas. But the other one was going up to 300 degrees. This one is 1,300 degrees system. Again, it was funded by Innovate UK, led with United Utilities Company and Stopford. And it's looking at basically water waste and how we can convert the slurry into some biogas pretty much. And my main role in that project, again, it was to develop the graphical user interface, the automated system, which will be able to control all the microwave units at the same time, as well as monitoring all the gases that are being emitted and the ones that are being created, as well as the temperature profile across 14 thermocouples between the entire system. So the system is now installed in the industry, which is absolutely fantastic to see that as well. So it is quite a high tier level. You can see one of the meetings when the technology was sort of running, and just to show you how it looks inside, because I think it's absolutely fascinating, you can see how the material is coming through and free plasmas are hitting the product from every direction. And then obviously generates all the biogases for it. So it's absolutely fascinating to see that from inside of the chamber. So I end up that project, so obviously that was another expiry of my contract, so I've been looking for another opportunity, and I managed to come back to a water sensors, to microwave sensors, and we had a direct funding from the United Utilities Company who covered the cost of my employment, as well as 2 PhD students. So together we've been working on a development of, you can see the platform in the corner here, here. So it was development of a microwave system which could be distributed in a wide sort of water reservoir. In this case, it was drinking water reservoir, to capture if anyone has thrown any pesticides, insecticides into the water body. So we could pick up automatically if there was any sort of suspicious of something being dropped, but also from which location, which is more important to them to be able to sort of understand the source. And just to give you a comparison of the need of that project, currently the only way to sort of test it is you go with a bucket of water, collect it, you drive to your lab back, make the analysis, and then you know if there is anything infected or not. But that's quite a late stage then, obviously. And again, it's fun, you know, being able to be in a kayak in the middle of the day, distributing the sensors, so it's absolutely fascinating as well. But also, that's the first time when I was exposed to some other challenges that I never considered before. Because it was a water drinking environment, and it's industrial environment, we had to have additional permissions and licenses in order to be able to come close to that water reservoir. So again, we went through the full training, exams and everything. So that's something you don't really consider at the stage of the research, but actually it's very important. If you do work with industry, if you do work with various collaborators, you have to make sure that you have all those things boxed off. So that's the time when I sort of come closer to a senior lecturer academic position. So 2017 March. Rafid was one of my line managers during this time. And I wanted to sort of thank him for giving me the opportunity to sort of continue with the research. So rather than offload me with loads of teaching hours, he sort of been very flexible with me and given me that fantastic opportunity to continue building the research that I always love to do. So I do appreciate that a lot. But from this moment, because obviously, as you can see, there is a variety of various projects I was involved, so I'm not really focusing on one particular today. I sort of prepare them into 3 themes that I think they sort of spike the most among the others. So one will be the tropical disease applications. Second one is cultural heritage preservations. And there are some other opportunities that they arrive as a matter of other projects. So I will try to show them very briefly. So tropical disease application, I mean, it comes through those little talks and lab tours. So again, do not underestimate the power of a lab visits, conferences, workshops, because that's where you're making the most of the links. So on one of those lab visits, we had Professor Janet coming to us and sort of looking at what we do at LGMU. We've showed our concrete system, so the non-destructive testing. We had some meat sensors at the time. And there was a sort of idea of, since you're doing buildings, moisture, can we look at insecticide deposition on building fabrics? Can we actually detect them? And we said, well, we don't know. Obviously, we haven't tried, but why not? It's an opportunity. We're very keen to do it. And we had a very small proof of concept project. It was about 25K the first phase. But actually, throughout this year, this project has expanded into multiple externally funded multi-million projects, as well as we've established a collaborative lab as a part of the ICON project that Janet leads. So it's from a little lab visit turned to a little project, end up with quite an impactful research, which I will try to show a little bit of that. Otherwise, we might not leave by 10 p.m. today, so I will try to keep it nice and smooth. So the initial project was looking at the problem where in developing countries, for example, India, in this example, you're still fighting with vector-borne diseases like Visceral leishmaniasis, malaria, Zika. And one way that they try to work with it is through indoor residual spraying and sort of depositing a layer of insecticide in a building to sort of prevent the spread of the vector-borne disease. But the only problem there is the quality of that spray, of actually how much spray has been deposited. And I will show you a short video in a moment why there is a problem with that. But before I go to that, we had, as I said, a stages of the project. With the first little phase, we managed to get our laboratory units, VNA, into the field in India, which don't really tend to do at the beginning, but you have to try. With a car battery, because in some places there's lack of electricity, so you need to make sure that you can power it off. So we've been collecting data among 28 houses, I think, at that stage, with, as a part of this indoor residual spraying. So we've been lucky enough through the collaboration that we could actually partner with the actual program of spraying. But throughout the next stage, because we had some very great results, initial results, we went to phase 2. And we managed to miniaturize the technology a little bit. So now you can see this sensor here. Still portable, okay, but it's operated by a motorbike battery instead of the car battery. So you still don't really want to carry it. And the phase 3, which will go along, it was using a self-contained unit, which you can see sort of in this area here, where you come to the wall, you touch the wall, and immediately the algorithms will make the assessment on the quality of that spray. So I said I will promise a short video why this was the problem. So the people supposed to be trained, and they are trained, they're going through a training, and you can see it's very important on the pace of the application of the insecticide, so how far you are standing from the wall, how much you sort of overlaying from one layer to the other layer, just to make sure that you are close to that correct concentration. Now, in reality, as always, you might have some other options, and that sort of shows you why that quality might not be of the highest level. But again, throughout the years, because we've been part of this program, we have managed to sort of initiate the impact from early stages, because even our presence there was sort of contributing to the people doing the appropriate way of spraying. And sort of with the years of the visits there, we managed to improve that quality of spraying. But yeah, as always, there are challenges, and we know them. So obviously COVID was one of the biggest challenges among all of us, to be honest. But again, it's a funded project, we can't stop it. So what alternatives we've got to continue it? So I had to sort of, assemble temporary laboratory. I sacrificed a little bit of the kitchen, so sorry to my wife, but she was quite fine with that. And obviously I couldn't work with our arrays, so I sort of get my daughter as a volunteer, because we did appreciate those end users, so it's not me doing it. We needed that sort of practice to see if there's any problems with technology. So we had a lovely volunteer to collect some of the data. I hope we have no one from HR. Obviously, we've not been paying the person, so. But then we actually managed to deploy those technologies into the actual field for the assessment. And one of the examples you can see here how the technique works. Within seconds, you can estimate the level of the insecticide on that wall. So, I don't know, it was quite quick. I'm not sure if you've seen, but there will be a LED showing what is the concentration in that location of the measurement. So, again, another collaboration with LSTM. So again, looking at those opportunities, we had at that time internal funding from Global Challenge Research Fund at LGMU. And we had some of the conversation about this project prior with Janet, Rinky, and Mike. And we thought, why we not apply for that Global Challenge Research Fund internally at LGMU, see if we can get initial data and then sort of see where that seeds us. So we won that 25K. We get the initial data collection, and then luckily Janet was in some of the meetings, and I think Rinky was doing some presentation on the conference. And again, through those events, we have managed to attract the funding of 1.1 million from Bill and Melinda Gates Foundation to take that concept further and develop it into a wearable technology. So you can see some of the early steps. Again, we always start in the laboratory to get that baseline data. So we've been doing some dielectric properties measurements. Then we've done some cavity sort of data collection with the liquids, with the blood samples. And then we wanted to bring it closer to real environment because, again, it's going to be applied in the field. You need to try to simulate the environment as much as you can so that you can replicate some of the challenges you might find out in the real life. So we've done the blood in the tubes. Actually, I didn't explain where the lymphatic fluidices come from, actually, what was the challenge with it. So realizing of that, the whole problem was that lymphatic filariasis is a parasite that sort of filtrates in your capillary system, if I remember right. And obviously it's getting activated only at the night time. And the only way at the moment to measure it is by taking a blood sample, which again, in a field environment, it's quite difficult to get people buying off to sort of provide you the blood samples at night, where then you have to take them under the microscope and see if you can detect those parasites or not. So that's where the entire idea of the project comes from. So then we had an opportunity to go to India again with partnership with AIIMS Patna, which is a sort of medical research institute, but they also work with a local hospital. So that's where we've been able to replicate our initial laboratory study, but also they gave us an access to the real patients where we could put our first phase of the prototype, which you can see here. Still a bit bulky, still a bit of a work to optimize it going forward. But we have managed to put it up to 150 patients in total throughout 2 or 3 field studies. So we are sort of looking at the data now, it was happening recently, and see if we can expand that project going forward to a next phase where we could optimize it and distribute it onto a wider population. Also, as a part of these collaborations with India, especially with the insecticide project, because of the successful results of the work in India, we did secure further funding from Bill and Melinda Gates Foundation, where we could actually deploy those technologies into Africa. So again, expanding from one country, from one insecticide to Africa with several insecticides for the detection. So moving a topic a little bit, again, through the opportunities, cultural heritage preservation. So we had a project, ongoing project called DigiArt. I wasn't a part of the initial stage of the project, but due to some personal circumstances of staff that had to leave, I was asked to see if I could join that project and sort of support the team in delivering the technology and obviously the delivery of the project itself. So I said, well, it's not really my part of expertise because it was all about VR, AR, and sort of making a cultural heritage closer for the tourists. So I was trying to see, how do I think to it? But actually, again, through the attendance on various events, conferences, we've managed to establish various collaborations, which I will show in a second. So that's one of those events I was mentioning. We've been invited to Parliament, to Brussels, European Parliament, where we've been showcasing our technology. We had 100 journalists from 28 member states using the technology. And we were the only one project at that time which was funded through Horizon 2020 that had a live prototypes set, okay? Sorry. So out of all of those projects, we've been the only ones successful to demonstrate the live demos and actually have the active sort of virtual heritage sites to interact with. And based on that, I was invited to loads of meetings in various consortia of other projects, which led to meeting Warsaw University Technology as one of the sort of collaborators, which then I thought of, okay, why don't we come back to our sensors? Sensors, it's easy. It's much more adaptable for me rather than some other, difficult concepts of AI and VR. So we thought of, okay, so we've done the non-toxic testing for building materials. Why don't we combine that with the digitalization technologies and sort of create a platform which allows you to digitalize the cultural heritage, but also make an assessment of, for example, how much moisture is it in the structure? Is there any severe problems that might be arising shortly? Do we need to, where do we put the resources, money for the refurbishments? Because again, the cultural heritage sites, they do not have millions of pounds available for refurbishments. They do have to sort of check their budget and see what they have to prioritize. So we've started working on that concept. We did apply for several Horizon Europe projects, but unfortunately up to the moment we didn't have a luck yet, but we're not giving up. But we did build quite a big consortium of cultural heritage sites as well as technical partners who are very keen to take that technology forward. So we do look forward and we see that hopefully with one of those grants we'll be successful and we'll be able to put that into practice. But we still managed to do some of the work. We don't like to put things onto the shelf. I do like to see things being used in real life. So we had a permission from a royal castle in Warsaw to access their 16th century untouched basement. Okay, they had a big problem with a moisture in the building itself, and because there's lots of underground rivers where the castle is located. So can we use our technology to monitor the progression of that moisture throughout the walls, throughout the sort of the basement themselves? And luckily enough, I think last summer when I was in Poland, while we've been doing our measurements, suddenly we got the notifications. We have, as a royal castle, obviously they do loads of events. They had a minister of culture in the castle, so he was quite willing to come downstairs and see what we do. We had a live Polish national TV where we had to demonstrate live how the technology operates. So again, from those little things, those sort of opportunities, it can turn around to quite a big sort of projects. And the outcome of that is, because the castle had an issue with a moisture, we've been working with them 4 years now. 2 years ago, they secured the funding to dry out the basement. So now actually they moisture-free, or reduced moisture level. So it's a very impactful for them. I was presenting to their director, again, on my last visit to Poland. So they give us a clear access to access any other buildings on their site to see if we can sort of replicate that data collection and sort of let them know if they're having any significant problems. Now, beyond, so again, coming back to opportunities arising from the events, workshops, and also I think it's important as a researcher is to think outside of the box, okay? See obviously you know your expertise, how can you contribute to some other projects that might not be fully relevant to you, but you might find that little thing that sort of keeps you to it. So a project called BioWaves, it was a Horizon FTI 2 years project based in Ireland. So the project was about using high microwave power in anaerobic digestion, pig farm environment. So we've been traveling on ferry on a Friday evening, getting to Ireland on the following morning, going to the site, collecting the data. But again, I've learned one valuable lesson in there. Sorry, Andy, I'm gonna have to mention that. We've been sampling product, pig slurry, every 1 hour, obviously for the chemical tests. And I think that was, Andy's, the most valuable lesson in life. You don't throw a liquid sample into the wind. But you have to look at the positive sides of that. When we're back to the hotel, even obviously after showers, you go to the restaurant to have some meal. You will never have any better VIP treatment than we had at that night. All the tables, 50 meters apart, were empty. Okay? We had a private waiter giving us a dinner, the beer coming very fast, So that was a really nice experience. But coming back to the project itself, the system is still in operation in the farm. According to the lead partner, the use of this system has contributed or improved their biogas production by 40% and reduced the overall CO2 emissions by 37% per annum. Okay, so it's again quite an impactful results of how you can turn a small laboratory project, because this started as a concept, and through different stages we managed to get it into a full-scale system installed in the industry. Similar with a BioDye 2020, so that's the project I've mentioned from the MSc, so it's contributed to secure that grant. And we've been looking at, again, high microwave power in here, and using a pre-esterification process. How can we enhance pre-esterification process by using microwave spectroscopy? So again, it started from very small proof of concept in the lab, as you can see here. It was in liters, I would say, maybe not even liters. It went into a full-scale 80 meters cubic per hour system. So it was very impressive to see. But there are always challenges, and we did have a massive challenge with this project. One of them being that the main equipment, the 36 kilowatt microwave generator, did not arrive on site until 6 months later. There was a 6 months delivery delay between 24 months project, so it's significant. So how can we overcome that problem? We have built a smaller scale 75 liters system between LGMU facilities. But the other thing we have to consider, we didn't thought at that time, we sort of find out halfway through, it's an ATEX2 zone, explosive zone, okay? So we had to go through a various challenging sort of certification to make sure that we can actually switch that thing on, not just at LGMU, but also at Scotland, where obviously the entire site was based. So again, when you're doing research, sometimes you don't consider those little things, but they will come back faster. So you have to act on them quite quickly. And coming towards sort of the end of the projects I wanted to highlight today, we've been approached by a military project, so DASA, and we applied for a project for the detection of hazardous biological materials. So again, as a work we've done with LSTM, with the insecticide project, because we've proved we could detect different insecticides on the surface, can we actually detect a hazardous biological materials also on various surfaces? In the situation, obviously, of the war, before sending soldiers, can we deploy sort of unmanned vehicle which could scan through the area, and sort of with this technology, can we also identify if there is any biohazards or not? So we got funding, and we've developed 2 systems. So I would like to show you very quick videos. One of them, you can use a horn antenna system. You've got 3 wooden samples, one of them without any biohazards, one with one type of bacteria, and the other one with a second type of bacteria. I cannot tell you the names because I don't know. We haven't been told. We were not allowed to know of what we've been dealing with. Obviously, we had to sign off our lives away while we've been undertaking that project. But what you can see is how that microwave spectrum is changing its signal as it's come across to different contaminants on that board. So the middle one, the blue one, sort of ish area, it's when there is no biohazards, and those 2 are basically 2 different biohazards on different samples. And you can see in real time how the system can adjust into it, and you can identify if there is any hazard, and if it is, what type of hazard. So that's one system. And the second one is more for portable applications. So again, we've got a handheld system unit with a sample which has been contaminated. We developed the entire graphical user interface with the algorithm behind, so that for the user, it is user-friendly to use, because again, you don't want a sort of very complicated system which non-technical people could not use. So it has to be quite easy to access for everyone. So you touch the sample, and you can see on the screen, I will pause it in a second. Yep. Yeah. So you can see what type of material that sort of biohazard was exposed to. So it was on a wooden sample, which bacteria it is, and also what is the concentration of that bacteria pretty much in the real life assessment. Okay, so finally, again, coming back to workshops, coming back to events and those opportunities, I was invited together with LSTM team to join one of the malaria conferences, which was back in 2022 October time. And again, not my field of operation, so I was only engineer in the probably entire conference, but I really enjoyed it. It was, you could listen to all those challenges, problems that people are facing, and straight away you start thinking how you could solve some of those problems by engineering solutions. So I was delivering one of the invited talks there on the alpha sensor, and there was a person in the audience from Army Forest Research Institute of Medical Sciences of Thailand. And after the talk, she come and say, look, we need that technology. Can we put that on a military uniforms? Is it possible? Since Janet was there, we had a conversation pretty much straight away. We come back, well, we're happy to try. We put a joint proposal with Thailand to a deployed warfighter protection, so US military, and just before Christmas we've been awarded the funding, so we're just in a contract signing process, so hopefully very shortly we will be able to sort of translate some of the work we've already done into a new application. So again, I think that leads me nicely to two more things. One, celebrating achievements with your team is always important, regardless of how big those achievements are. I think it builds that community and support. But finally, it takes me to the takeaway sort of messages. So one of them, as you probably could notice, I was mentioning opportunities constantly throughout the talk. It's maximizing those opportunities from turning small concept ideas, those wacky ideas, into the external grants. Second one is communication and collaboration with industry and other academia. It needs that breaking communication boundaries because obviously we have different research expertise, so we do a little bit talk different language. We've learned with LSTM, we've been sort of calling things differently, and until now we sort of make mistakes from time to time, but it keeps us laugh. But from there, it's very important to remember the boundaries and, listening to each other and how to sort of accommodate those challenges. And next one is being able to explore various opportunities, but eventually try to bring it back to your research opportunity, to your research background. So again, like with the DG art, that was not my expertise, not my area of research, but actually we found a gap of how we could utilize our expertise of sensors in the same area and combining both together. Patience is the key, and probably I'm not the best person to say it because I'm not patient. Anyone who knows me, they will tell I'm not a patient person, but I know it is a key. I try to work on it, but it doesn't really work. But it is the key. And final one, the one I love the most, is breaking those it cannot be done, it's impossible to be done. I always try to break that straight away. There is always alternative solutions. Nowadays, where everything's progressing so fast, pretty much everything is possible. You just need to wait and find the appropriate solution to it. And probably the question you would ask is, what would be my next goals? And obviously, yes, I will continue with research, absolutely. Obviously, depending on the opportunities and how they arise. But I think one of the biggest future goals I do have at the moment is obviously inspire my kids to do the things they love. It's not like I'm pushing them to the engineering, but slightly I do try to persuade them a little bit. So we'll see how it goes in the next few years. Maybe they will be lucky enough to join LGMU at some stage as well. And at this stage, I would like to thank all the partners and funders for obviously providing the funding for the collaborations and all these opportunities that arise throughout those years. And some of the individual people that relates to obviously different projects at different stages. So again, I would like to thank everyone, and obviously I'm looking forward to all future collaborations. And that will sort of conclude my lecture. So thank you very much for it.
Excellent, thank you, Patryk. I think what we've seen tonight is an excellent lecture. I think you'll all agree that demonstrates that sort of the depth and the breadth of the research that Patryk's involved in. What's even more impressive, he can stand there for an hour and multitask between fatherhood and lecturing on what is an area of activity that he's clearly passionate about. So thank you very much for the lecture. And on behalf of the university, can I just present you with a commemorative gift for this evening's lecture. Thank you, Patryk.
Thank you very much.